So this is another question in the series of projectile motion. Um, the problem states that the diagram here shows a box moving along a gray wall. The height of the wall and the speed of the box just before it leaves are shown in the diagram. So the height of the wall is here 6 meters, and the speed that it that it leaves from the wall is 4 meters per second horizontally. Given this information, how far will the box land from the base of the wall? So we're just trying to find the change in x. Assume the top of the wall is frictionless and ignore air resistance. So we don't have to consider any other forces. We just have to look at how far it goes horizontally. So we're trying to find this change in x. If we keep things simple, we will use the coordinate axes provided in the question. So up is plus y, to the right is plus x, and well, down would be obviously minus x, and to the left down would be minus y, and to the left would be minus x. Now, if you notice, the question says there is constant. It implies this constant velocity in the horizontal direction, because it only says it's 4 meters per second. And then it also implies that it does say to use g is equal to 9.81 meters per second squared. So that means that there is a vertical acceleration pointing downwards of g. Now, since we're using down as negative, it'll be minus g. Well, as acceleration is constant, we can use the constant acceleration formulas. One way to do this is to look at both vertically and horizontally. Write two separate equations. We'll write what we have, what we're given, and what we need to find. So we let x of 0 equal to 0 meters, and we let y of 0 to be equal to 0 meters. Now notice the change in y is 6 meters, and that means so that means that this y of 0 is equal to 0, then down over here, it would be, since the change is 6 meters, down here it would be, well, negative 6. So therefore y is equal to negative 6 meters. We know the acceleration is equal to negative 9.81 meters per second squared. And in the horizontal direction, we want to know what x is to find the change in x. And then with these two, we can find the change in x, which is just x minus x naught. And as x naught is equal to 0, it's just equal to x. So we just really need to find x. So I can just rub this part out. All right. We don't know time. What else? If you look at horizontally, we know the velocity is constant. So we know v is equal to 4 meters per second. We know the initial velocity is equal to 4 meters per second. And so is the final. And we know that since the velocity is not changing, and acceleration is a change of velocity over change in time, we know therefore that the acceleration is 0 meters per second squared. and we know nothing else. We need to find x, so we can try that straight away. X by using one of the projectile motion equations, x is equal to x naught plus v naught t plus half at squared. And the problem is we don't know time. So what we can do is we can use the vertical equations to find time and then substitute that into here. Anyways, so the goal is to find time over in the vertical direction first. Alright, so we can use the same equation. Y is equal to y naught plus v naught t plus half at squared. And, well, we know y naught is equal to 0. So that goes away. The initial velocity in the vertical direction, well, it's 0 because it was just moving horizontally. So let's just let that equal 0 meters per second. So therefore this is equal to 0. So we just have y is equal to half at squared, and we solve for t. So it's 2y is equal to at squared. T squared is equal to 2y on a, and t therefore is equal to square root of 2y on a. Now we know y is equal to -6 and a is equal to negative 9.81 meters per second squared. And we substitute that in, we get 2 times negative 9.81 divided by, sorry, it's 2 times negative 6 divided by negative 9.81. So that becomes square root of 12 over 9.81. Now we will use this and substitute it back in actually we'll simplify it first. So that's approximately 1.106 seconds. And now we just have to substitute it back into this. Well, we know x naught is equal to 0. And well, we just and then, well, acceleration is 0. So it's just x is equal to v naught t. And then that means x is equal to, well, 4 times, well, 1.106. So x is approximately equal to, well, 4.42 meters. And that's it.